Hello YouTube vintage stereo collectors and restorers. This is sort of a restoration video. It has to do with fitting things in tight places. As you can see here, there's sort of a logjam of capacitors, a diode bridge. This is one of these Kenwood Trio KT1000s, the early 70s version. And it's funny, this keeps happening. This is the third person that I know vintage auto collectors said, if you see one of these, I would like to buy it, especially restored and working. And so in the last 6 months, I've done 3 of these. And they're nice compact tuners, the same size as the KE2000. But anyway, I just want to talk about refitting capacitors. And we're starting to run into a problem these days. And that is finding reasonably priced axial capacitors. So that's a 25 volt 1000 microfarad. This is a 50 volt 1500 microfarad by IC. These are now over $10 a piece Canadian, and sometimes not in stock. I actually bought these on Mauser, and it showed them as discontinued. So I think when they're gone, they're gone. There are fewer and fewer companies making axial caps, and I always think of the Flintstone car going down the road, right? Now, that's actually not that big a deal. There's actually a workaround. I used to do this a lot, especially when, you know, somebody said, I don't want to spend a lot on it, don't order any special parts. You can actually use this cap here. Well, I know it doesn't have 2 places to solder onto. I'm going to show you how that works. What we have to do first is desolder these, and there's quite a bit of stuff here. It's a bit of a pain, actually. First thing I'm going to do, there is no schematic that I can find for the KT1000, the 2-board version, like this one here. It's going to mark where the negative bands are on those. So what we're going to do, we're going to just snip that one right there, lift it out, and see, this is a 30 watt iron. Let's see if we can kind of unwrap this one. Yeah, not bad. That's actually not too bad. Of course, we have another cap here that we should replace too. So I think let's take that one off too. I mean, we're not going to leave this piece of junk in. Hopefully you can see what I'm doing, alright? I'm going to just give that one a snip. Okay, what is this? Snubber cap, 0.022. Alright. Okay. I am going to solder. I am going to switch. I'm going to heat with my left hand. Get in there without burning myself. So actually that resistor is wound on top of here. So we may have to lift that off too. It's the price of admission. And I know there's some out there that would say, leave that stuff in. Yeah, I know. That's a common resistor. It's a brown, black, brown. So what is that, 100? I don't know, or 1K. Let's just lift that end out of there. Let's throw a meter on it to see what it is. How close it is. Yeah. Okay, there we go. Put a meter on it. So, yeah, just not making good contact here. So 100 ohm resistor is coming in at 148. I find that's very typical of those, especially if they've been in a section where they're dropping a bit of current and voltage. No problem, I will change that one. We'll just clip it out. We'll clean off this here so we can do a nice wrapping job. Oh, I see what that is. Okay. So, the lead from the filter cap actually is used to tie onto this place here. It's just... one little piece that's stuck in there. It's always something, isn't it? There, we got that opened up. And the one over here, which we snipped there, so they're tied to a common point. Now, pull that off. Let's get rid of these pieces. Make sure I don't drop it on my foot, right? There, okay, so a little bit extra solder on there. There we go. So, here's what I want to show you right here. So, taking out these axials. I have some radials. These come in around $4 a piece. And really simple little thing to do. The end that goes to the negative side, you'll hook in like that. So the other end, we need a little shrink tubing to do this. So first of all, we get some shrink tubing cut for the negative side. Like that. And then what we're going to be doing is we're going to be bending this around and alongside here and hooking it back here, the positive lead. It is, I don't think, long enough, but let's just do a trial bend. Yeah, it's not long enough. You don't want to bend it too sharply right there because you're going to end up shorting the cap out. So we got to do a little extension on here. We're going to put a hook there. Strip the ends. Put a little hook in it. I have to solder it to the chassis. So there it is soldered. Now we just need a piece of tubing that'll get us over that point. This one might be a little too short, too small. Yeah, we need to go up one size. We got lots of tubing, so this is the greatest stuff, you know. I remember the first time I bought some shrink wrap tubing. I was just like, oh my, isn't this great? We're just going to put it back. Just heat it up a bit. I just marveled at it. Mainly because you can cover up your mistakes. Now it makes things nice. Try not to get too much heat on the cap. So what you're basically going to do is then do a bend that runs beside the cap. So this is going to go in to the ground. I still have to replace that one resistor. And we'll hook this side on here. So basically, it's going to be going in like that. I'm not going to install it yet, but it's a way you can use a radial in place of an axial. But let's say we have that 100 ohm resistor to change. And you can go on and on. I would change the snubber caps, which are in parallel with diodes. So this is a rectifier bridge, but it's a 2 rectifier bridge with a center tap transformer. And even over here, like we have the 16 volt 220, it's grounded to a lug right there. And to here, you could actually trace this back. See that white wire to there? You could actually put a smaller, more modern cap right here and solder it down to that point. You don't necessarily have to put it exactly where they did at the factory. In fact, if you look at this, ground, ground. We could just take a 220 microfarad radial cap, I think that's what I did in the last one, and have the ground lead there and the positive lead there. As long as it's grounded to chassis in a similar manner, that'll work fine. So that's what I'm going to work on. I'm going to recap the power supply in this. The rest of the tuner seems to be working really good. All the lights are still working. It still has the fuse lamps. So I'll show you the face of it. It still has the fuse lamps with the green, kind of green cellophane over them. Yeah, it's just one of these, just a small tuner, a discrete tuner. There aren't any ICs in this, and there are a couple different versions of this. I figured this out a while ago. This is the early version, so this would be about 1968 vintage. I don't know if you're seeing that board. I'm just going to bring the camera up a bit. So it has the FM section here. The FM IM has large. IF has the large cans. The AM has the small. And there's a shield that goes over here, which I've already taken off. Well, this one doesn't have a FET, but there's a later version that uses one single large board here that does have a FET. I actually can't tell the difference between the two. They both work well. Anyway, thanks for watching and listening.